My name is Meng Wu. So we basically a semiconductor business coming from Silicon Valley. We focus on the wireless connectivity part. So when you're talking about 5G, next generation Wi-Fi, that's us. I just quickly go through the slides since we kind of running down on the time. So that's the so what we our name is Parmacell Semi Design, and then our Chinese name is Boma Wulian. Our key competency is RF technology, like radio frequency technology. So when you talk about semiconductor space, you have the digital designs, you have analog design. The analog RF is one area China is in huge shortage in terms of skill set. So we are the leader in the next generation product, in the next generation IoT connectivity product, and our strength is in RF design. We'll just give you a broad view of IoT. People have been talking about IoT for the last few years, and if you look at the China market, for the last 3, 4 years, every conference we go attend is basically talking about NB-IoT, which is kind of supported by the Congress, the Chinese Congress, to promote that. But NB-IoT relies on the base station. So in other words, every single chip is like our phone, 2G, mobile phone chip. You need the China Mobile, Unicom, or this carrier to support it. Whereas for some industry applications, say Industry 4.0, you have factories that do not prefer have your data uploaded to the carrier, like Vodafone or those ones, and you have to buy it back from them. They want to own their private network. Some of our use case we talked about is like the Canadian nuclear plant, where they want to have very high security levels. So they want to own their own private network instead of using the cellular network. And for the smart city in China, most of the use cases, 80% of the IoT in China right now is in the smart city area, mostly the security cameras and the water meter, gas meter. Whereas for agriculture, smart home, transportation, a lot of things were in discussion. So if you look at the current use case in China, we're very beginning of the IoT age. And if you look at it globally, China is actually the leader in terms of adopting the technology because one is government is very strongly promoting it. Another one is that the government already set a communication standard for all these IoT device instead of in the States where people let private enterprise to compete and to let the best technology come out. In China, it's different way. It's more government driven. Because of that, they actually become a leader in the space because everyone knows what they should be doing. They just need to find out what the applications are, what the use cases are. So that makes a very fundamental difference. So when I talk about infrastructure, IoT, you have different applications, like a smartphone is one application. You have your smartwatch, that's one application. You have your smart cameras, all the things. But all these applications require wireless connectivity. They need to get to the cloud. The cloud do the computation, storage, and provide solution for people, right? So we are at the stage of building the infrastructure. 5G is infrastructure. When they're coming out, that's like when 3G come out, that's when we can have smartphone. The 5G come out, we have different dynamics. But we do not know what killer app the application is going to be in the 5G time. But we're all in a space to explore. So people talk about IoT. You're really talking about a variety of different use cases, but some of them will become the killer app, like the smartphone. Every 18 months, every 18 to 24 months, people change their smartphone. There'll be similar thing happening in the IoT space. So this is kind of projections from the World Economic Forum. They talk about next year, the number of devices connect to the cloud will be around 50 billion. And then going forward by 2025, the market will reach 1.5 trillion US dollars, and the number of devices connected will be 310 billion. But that doesn't, it's just very fancy number. What really matters for all of us, I suppose, is about what killer application that's going to be in the IoT age, in the 5G age, right? That's what we're really looking for. So if we go to the wireless space, generally there are two kind of standard in the wireless. One is 3GPP. So when we talk about 2G, 3G, 4G, 5G, that 3GPP standard, that's the one that you use your mobile phone, connect to the carrier network. Huawei provide all the infrastructure to the carriers in China, and then They'll be able to build their base station. You connect these to them. That's 3GPP. That's wide area network. There's another one that when you go home, when you go to office, you go to hotel, you connect your phone to the Wi-Fi. That's Wi-Fi standard, IEEE standard. The Wi-Fi one is called 802.11. So at the beginning, we start in the late 90s. That's 802.11 AB. And then we reached GN, AC, the most recent one. The traditional Wi-Fi, short distance, high power consumption, and high data rates, that's AX. Whereas for the IoT space, that's called AH, called Halo, which is, I think I can get the light over here, which is this one. And we are the leader in this one. And then Huawei and Qualcomm, they lead in the NB space, NB IoT. But again, Huawei's strategy is that they do not try to make money from the chip. They try to make enough people designing the chip, and then they will provide their infrastructure to the carrier. So they will make money from that way. Whereas in the Wi-Fi space, every single device you connect to the Wi-Fi is all cost-free. You don't pay for your usage, unlike your phone. So we believe the wide area network and the local area network, these two will be a complement for different use cases in the IoT age. So if you look at the global connectivity, you have the NB-IoT, which is the 3GPP standard, wide area. You also have the Wi-Fi space. If you move from the short distance, from 0 to 10 meters, that's when we use Bluetooth, Zigbee. I think most people are familiar with the Bluetooth. That's personal area network. Once you reach from 10 to 1,000 meter, that's when you use Wi-Fi. So the Wi-Fi is when you get home. The home Wi-Fi, traditional Wi-Fi is around 50 meter to 100, whereas the new generation Wi-Fi can get up to 1,000 meters. And from the 1,000 meter up to 10K, that's a metropolitan network. These ones are where people use like LoRa's with different technology, mostly proprietary. And from 10K up to 100K, that's when you use wide area network. That's when you use your phone to connect to your base station, to China Mobile or those carrier Vodafone. These are the wide area network. If you out of our own experience, these two, the Wi-Fi and 3GPP, the WAN, these two will be the major connectivity solution for most of the use cases. It has been the case. Going forward, it's likely to be like that as well. So if you compare Halo, like the new technology with the old one, these are traditional Wi-Fi. If you go to your home Wi-Fi, the latest one will support 802.11 AC. You see that they got high data rates, but also the distance are short, and the number of devices to support and power consumption are high. Whereas for Halo, the coverages go up to 1K. So for industry, I can show you some use cases later. For industry, where they need longer distance other than 50 to 100 meter, they want the longer up to 1K. That's when they start to use new technologies. And the number of devices they can support get up to 8,000 compared to what they used to be. And also the power consumption gets a lot lower. This is something that a lot of people I talk to kind of ignore in the IoT age, because a lot of use case in IoT, the number one priority was power consumption. A battery can last for years, sometimes even decade. For the nuclear vault use case I talked before, they only open the vault every 5 to 7 years. They can't change the battery, and they do not want to get a wire into the vault. They need something support for a very long time. This is what Halo compared to the existing IoT technology. A lot of people talking about LoRa in China these days. They have LoRa Alliance, CLAA, ZT CLAA. We talk to them as well. They have, if you compare the technology, these two are the old ones. The old ones, the type of data rates they support is BPS, where this one is kbps. That's when you kind of can reach voice transmission. But if you want to get up to the voice level and also get up to video or pictures, that's when you need a new one, like the Mbps type of data rates. So for some of the use cases we talked in Shenzhen, they're doing the smart construction. On every helmet, they have a camera on the top, and they also have an earphone, so you can talk, and then you want a private network to basically monitor the construction's progress. So when people talk, they need to transmit voice. That's when you start to need higher data rates. And then if you compare Halo with some like the Bluetooth, again, distance up to 1K, the data rate is a lot higher. And this one, like NB-IoT, these three were the old technology. These two are the new one. And the NB-IoT is for the cellular, which means you connect to your base station of your carrier. And Halo is Wi-Fi. All these communication technology, they are the infrastructure of the new age. Because every single device going forward or killer app you're going to discover in the world, they're all going to be wireless. If you connect to the TV right now, you look at all these screens, like they still, apart from the power wire, they still have like the HDMI or these wires. Going forward, all this is going to disappear. They're only going to have the power wire left, and then maybe one day will be gone. So all the new killer app, they're all going to be mobile. They're all going to be wireless. So two major wireless solutions we believe. One is LTE, which is the 4G or 5G next generation. Another one is Wi-Fi Halo, which is the Wi-Fi standard. So if you think about every single edge device, this edge device, they would have several different functions implemented before they become usable. But wireless module is the one that is very highly standard. This is the world that we picture in the future. The four different major use cases we see in the world. One is consumer consumption, like smart home or smart home or smart hotel. Medical, that's the space where we see a lot of efficiency can be improved. A lot of people go to hospital. The first thing they have to go to the blood test, or they have to test their heartbeat and blood pressure, things like that. But the current device, the wristband, if you buy, like you can buy from any of those online shops, they can tell your heartbeat or this type of health biometrics alive. But they still need that to connect to your phone to be able to have access to the cloud. So going forward, all these things should have their wireless connectivity directly to the cloud, to the internet, other than through your phone. This will change a lot of things. So when you go to the hospital, regardless which hospital you go, where out in the world, your information is on the cloud. As long as you allow them to see them, then everything is integrated on the cloud. So that's medical application, logistics. When you have products, especially high value added products, transport on boat or on the flight, once you get on the boat or get on flight, you cannot rely on the LTE 4G network anymore, neither 5G. You have to rely on satellite to connect to the Wi-Fi on the boat or on the flight, like A380. You have the Wi-Fi on the flight. Those ones are the ones be able to monitor the product during the transportation. So if you think about if there's animals or you want to manage the temperature of a certain container, these things can only be done with Wi-Fi technology. Industry 4.0, again, the requirements are private network, and then for certain area, they may not have very good cellular signals, and you cannot build a base station yourself. You have to rely on the provider like China Mobile to build a base station. So for those space, you want a private network because you can add your own Wi-Fi next to where you want to get the connectivities are and enhance the signal over there. So these four major use cases with the cellular network and the Wi-Fi will connect every information to the cloud. On the cloud, that's when they do the computation and provide the solution. I remember when I read online, people talking about once the 5G come out, what's going to be like. There's one thing I think a lot of people may not realize. We pay very expensive for our phone. A lot of because of CPUs, and memories, and then the GPUs over here in the phone are quite expensive. 90% of the profitability in the phone goes to a semiconductor designer. Apple is a designer. Apple doesn't have a factory. They're the largest company in the world. They design. They do not manufacture. They all outsource to Taiwan, to Korea. The designing is where the high premium add. And then if you think about if the connectivity become absolutely flawless, that's when on the phone, you do not have a processor. You do not have CPU. You want to have GPU over there. There's no memory card. There's only connectivity and the display. That's all. So that's when the phone become really thin, at the same time become really cheap. And you may not have a phone anymore. These are the things will change dramatically once you have the new infrastructure, the 5G, the connectivity. Another one is this is actually what Alibaba talked to us before. They want to basically, when people order products online, the customized product, they want to monitor the entire production, goes on to their warehouse or get on the transportations and deliver to people's home. They want to monitor all of this and also use experience with their own, with their voice box at home. So all these things will require wireless connectivity, and especially if you do the transportation, say you go on the flight, that's when you need to rely on Wi-Fi instead of the cellular network. In the manufacturing, most of the cases, they want to have their own data control. They do not want to send the data to the cloud and then buy out from the carrier. They want to have their own ownership. So this is when the new technology coming in, and then which are both cellular and the Wi-Fi will complement each other. So this is smart hospital, like we mentioned before. There was a use case we discovered in China, where in the hospitals or retirement center, the elders will have like a wristband or chipset attached to their body, monitor their health conditions. When they go to sleep, their bed will have a monitor to see their blood pressure, their sleeping condition, all this use case. We've been talking to Professor Yao Jianquan in Tianjin. He's the number 2 guy in China for IoT. So these are the use cases. They've been given government grant to support, to develop. And these are the smart cities. We see a lot of this in Shenzhen and Hangzhou. And Alibaba and Tencent, they try to compete in the space with the carrier. So what they want to do is basically, instead of become a platform, they want to start to collect the data. So they believe the data is the future. And right now, with all the MB, all the data go to carrier. And so they want to build their own network to collect information. So that's another battleground. They're throwing a lot of money, billions, into this infrastructure to collect. Once you build out infrastructure, the private network is there. Everything mobile, once you turn it on, is plugged in. All the information, everything you use with that device will just go to their cloud. And smart city, that's another case of smart city. A lot of security use cases over here. Basically, some of them rely on the current infrastructure, like the 5G or 4G. And some new ones, especially doing Shenzhen, the SESEC, putting a lot of money to develop it's called a smart PO. So you basically have a PO over there. They support like LoRa or a variety of different kind of functions, camera, things like that. So this will be the access point for new use cases in China. This one is warehouse, and the factory. Again, in these use cases, they want to have their own private network, be able to deliver, be able to customize their production. In the old days, when we have one design, we'll probably produce 10 million of them. Whereas in the future, the chances are you would have, instead of like 1 at 10 mil, you have a 10 of 1 million orders. So everything become more and more customized. So during this transition, they will have a lot more automation required. At the same time, many of these things will be done without wire. The communication, the changing order, the changing the manufacturing technique will be done on the cloud. The cloud would basically do all the designs, use wireless transmission to control all the mobile robots, and then complete the manufacturing. This is the smart home. Again, Xiaomi is using Bluetooth and Zigbee doing this, but at the moment they're not quite preferable. Transportation, again, once you get on the boat, things like this, you can't get onto the LTE, 4G or 5G. You need to use Wi-Fi technology. On the flight, same thing. I try to quickly run through the use cases over here. So these are some of the data. Once you use the Halo technology, you have this is data rates for each of the use case, and these are the number of devices they can support. So you see some of the use case over here, like light controls or garbage collections. They can support within 250 meters. They can support 5,000 devices with one Wi-Fi, and whereas over here at 1K, it's still 4,000 devices. That is highly dependent on the data rates. Some of use cases like audio or video, high data rates applications, These are the data rates they support, which can clearly deliver. These are clearly deliver pictures, and these are the videos. And within the shorter distance, the more number of devices you can support, the longer, the less. And this is one feature for Halo. I can introduce you guys, talk a bit more about this. It's basically dynamic switching bandwidth. So you have a camera set up over here, or say the parade outside. Instead of having camera all put in place, you have cameras that they stick onto the wall, and use that with wireless connectivity. They can switch the bandwidth by the data requirements from very low data rates at 4 Mbps up to 86 Mbps. So for the IoT case, if you have a camera, say if you put a sticking camera over here, and then the door's closed, most of the time they be transmitting at these data rates, which save a lot of power. And then, but once you open the door, that's when they trigger and the switch the bandwidth to 16 megahertz. That's you transmitting at a high quality video. You'll be able to monitor what's going on. So these are type of, again, you have 4 major use cases with MB and the Wi-Fi. You connect everything to the cloud and use cloud to do the analysis and provide solution. Smart hospital, so I probably just quickly skip through all this. These are just use cases. Sorry. Working or? Okay. I think it's not jumping. So this is company background. I'll pretty quickly finish up. The company was funded by Silicon Valley veterans in 2012. We very strong at RF technology. We recently repositioned ourselves in Hong Kong this year, and then we're gonna do a lot of R&D in China, in US, also in UK. Our previous clients was LG, Neurocom, Samsung, Sony, Toshiba, ARM. We didn't put over here, but they're also in the list, and that's our technology. So if you look at Halo, these two are for IoT. And this is one is traditional Wi-Fi, next generation. It's called Wi-Fi 6, but 802.11ah. This is our facility in Texas. Most of the designers coming from Texas Instruments. And this is company's path from the past. We've been around 7 years. And this is our projection of our product in terms of the revenues and our strategic plans. The company CEO, his name is Roy Ju. They used to from Texas Instruments and being the CEO and the COO and president for these companies. This one was quite large, the 4th largest one in the world in the EDA space. And most of the people, designers coming from TI. So TI is the largest RF design house in the world. And then these guys were just from Magma. So these are our advisors, one from China, the remaining coming from States and Japan and Korea. So they have very heavy industry experience and knowing what they're doing. So that's about it. Sorry, I just went too quickly.
No worries. Any questions for Meng?
Yeah.
No? Oh, one over here. Let me march over.
Oh, thanks for the introduction.
Absolutely.
You mentioned the AH, you say is your standard, it's an industry standard.
It's industry standard.
So you're the only one producing it.
We are one of the 3 in the Wi-Fi Alliance. There are 3 companies in the world does it, and we are the leader in the RF design. No, they actually all are non-Chinese. So again, when we approach all these Chinese investors or Chinese clients, most of them just want the technology to target domestic market. And it's always come back to how do you want to divide this? How much? Firstly, you need engineers for the 2nd, 3rd generation, right? But how do you want to divide this? How much will be for the R&D team? How much you will give to the Chinese investor or the joint partner? I think that has always been a very interesting discussion. Yeah.